Here we are.
Slides.
All right. Well, for those of you who are in the meeting already, that came on time, thank you. For those of the rest of you that are joining as we go along. As you can tell, this is the Microsoft Azure user group. That's our website to the bottom, and we are recording the session, which we'll post on the YouTube channel. Hopefully tomorrow or by Monday, certainly by Monday at the latest. Okay, let's switch. So this is about a little bit about our group for anyone who's new to the group. Again, we're everything about Microsoft Azure, all levels of management and technical people. You know, we focus on, you know, on related to Azure. And although it's a little harder with virtual meetings, when we meet on premises, we do provide a good forum for internal discussion and conversation and networking among the membership. But we are, you know, hopefully when the pandemic subsides, we'll be able to start meeting up at Microsoft again. Because this is where we normally meet. We normally meet every third Thursday of the month at this time at Microsoft for food and networking and a presentation topic. Currently, we're meeting online only. And we've just, every month, it seems like I have to change this slide because we just went over 1,700 registered members. We always could use more members, so tell everyone you know about us. If they hear anything about Azure, this is a good place for them to be. And let us know what Azure topics you're interested in us covering. As it turns out, we don't have the schedule set up for 2021 yet, for subsequent months, but more about that later. Okay. This is the board of directors. I'm the founder, one of the two founders. Roger Dahlman was a co-founder. I'm the founder and president, and I'm a cloud solution architect by day. I work for a company called RedApp, a good-sized consulting firm that specializes in cloud. Okay. And Roger Dahlman is co-founder and vice president, and he works for Deloitte here in Nashville. Yeah, could you go on mute? I'm getting a little feedback sounds and things. Okay, thanks. Tim Warner is our board member, and he's a pretty well-known guy here in Nashville and actually worldwide. He's a Microsoft Azure MVP, does a lot of the Azure courses on Pluralsight, and has written several books. Ukela Alred is our director of academic outreach. She works with the colleges and universities in the area to
Oops. Hey, Bill, I accidentally muted you.
That's okay.
I'm sorry. Like I said, I'm new to this job.
Well, the pay isn't much, so we're fine.
Okay.
We're all volunteers.
What you pay for.
Right. So anyway, Tim, I don't know when it cut off, but Tim's in Microsoft Azure MVP, Pluralsight author, book author. Ukela is our director of academic outreach, working with the schools in the area, the colleges and universities to bring in new members. Matt Puckett is our meeting space sponsor. He has been for the past 7 years. And Matt has been moving up in the ranks at Microsoft. Now he's a Microsoft Principal National Cloud Solutions Architect. Also on the board is Jack Hagler from Vaco, and Jack has been our permanent refreshment sponsor for the last 7 years. He's a director of recruiting at Vaco. Okay. And again, on the subject of sponsors, we do want to thank our sponsor. Microsoft is our permanent meeting sponsor. I forgot to put on the slide that they also provide our meetup dues for us. So they pay our meetup dues. So they're kind of nice. Vaco's a refreshment sponsor. Vaco also provides this Zoom subscription that we're using right now. So that's very nice, and we appreciate that. And RedApp lets me spend some time working with the group. So we're also a sponsor. And we're also sponsored by the Greater Nashville Technology Council. In fact, I'm the chairman of the steering committee of the Nashville Technology Council Technology Group Leaders Committee that meets here in Nashville that tries to work with and help out all the technology groups in the city, in the Greater Nashville area. We do accept sponsorships. It's been a little hard where we're meeting virtually, but if you have anything that you want us to, if you want to co-sponsor a future meeting, you want to give us something to raffle off to our membership, we can do that. So just get in touch with Roger Dolman if you want to do that. Upcoming meetings, as I said when I started, we are preparing, typo here. We are preparing for the list for speakers now. We're going to send out a call for speakers. I like to ask people who show up at meetings to make suggestions about future topics, because if you cared enough to show up to the meeting, you get to suggest what we're going to cover in the future. So let us know what you think. That's my email down at the bottom. Also, if you're interested in doing a presentation to the group, we love to have people who are local do presentations as well. So just get in touch with us. And now I'm going to bring out our featured speaker, Doug Starnes, and Doug can tell you a little bit about himself, and he'll cover the main topic.
Okay, now can you hear me?
Yes.
Okay, great. Okay. Let me get started here. Let me get my slides up and I will share my screen. And that's not that's screen one. Okay, can you see my main slide, or do you see the presenter view did come up actually? Can you see my main slide and that's it?
Yep.
Okay,
yeah.
Because it said because what Zoom is saying is screen 1 on my machine, Windows says is screen 3, so I didn't know.
Oh wow.
All right. Good evening, everybody. Welcome. Thanks for well, at least coming to your computer, coming and sitting in front of your computer. For the next, I'm hoping I've got about 60 to 90 minutes of content. However, if I get logged on something, let me know when I've overstayed my welcome, and I will definitely shut up. But at any rate, for the next hour and a half or so, be talking about machine learning on Azure, and this talk. The title of the talk, this without or with a PhD. There's actually a number of these talks that I do that are all without or with a PhD. So there's a machine learning for .NET. There's a deep learning, a data science. There's a deep learning for JavaScript, actually. There's one for Unity. There's a natural language processing one. There's one that's computer vision, which oddly enough, nobody wants to see. But the thing about this is that I think that it's probably more applicable, this without or with a PhD, to Azure more than any of the other topics, because there are so many ways that Azure offers you to get into machine learning, whether you're a novice that knows absolutely nothing, or whether you're a more experienced practitioner that likes to get down deep into the code. And I'm going to try to touch a little bit on and everything in between. And I'm going to try to touch a little bit on everything. So I'm hoping that there will be something for everybody tonight. I'm going to go ahead and start. Whoops. Let's see here. Come on. There we go. I'm going to start off with what I call the obligatory narcissism slide, or about me. And so, like Bill said, my name is Douglas. I'm actually in the Memphis area. So I'm on that side of the state. And I'm actually in a little town called Oakland. It's in Fayette County, to the east of Memphis, about 30 to 45 miles from so-called civilization. And but I love to come to Nashville. I've actually been to the Azure group back when we were allowed to be within 6 feet of each other. I've been to the group a couple of times. I tried to get to Nashville about once a month or so. I'll go to the Python group, the .NET group, go to conferences like Pi Tennessee and Music City Tech. So I love Nashville. One day I may be able to say that I am a fellow resident. Who knows? So what I do to pay the bills, I call myself a professional explainer. Some people might call it an author. I don't know if I really like the term author, because kind of sounds like I'm waiting to be inspired to write a great novel or something. But I am an author, but I publish mostly video content. So Pluralsight, a site called Real Python up in Canada, and another site called Skillshare. Most of my content is around data science, machine learning, Python, although I'm actually beginning to do some in mobile development now, which is it's actually what I'm working on for Pluralsight right now. We're working on some Flutter content. One of the things I do in Memphis in the community is user group co-leader. So I'm part of the Python user group, .NET user group, Xamarin user group, Power Platform user group. If anybody is interested in speaking at any of those, our plea for speakers is continuously open. Please do not hesitate to get in touch with me, and we will try to find you a spot, because we're always looking. And especially right now, since it's virtual, everything's virtual. It's very, very easy to get people in. I also help out with a couple of conferences. So TDevConf, which you may have heard of because some of the organizers are in Nashville, Carl Kinghorn and Todd Merritt. They along with myself and along with the .NET user groups in Chattanooga, which is Brandon Schwartz, and in Knoxville, which is Dennis Stepp. About the middle of last year, we realized, hey, guess what? Everything's getting canceled. And so we wanted to give people an opportunity, give speakers an opportunity. So we put together a little one-day conference back at the beginning of October. Actually ended up having 35 people, 35 speakers, fantastic speakers that, so for a first run, it was really, really good. We are planning on doing a second edition this year. And then also Scenic City Summit, which normally is in Chattanooga in August, but last year was virtual in November for the same reason that TDevConf was virtual, and for the same reason that everything that was virtual last year. And last but certainly not least, I am a Microsoft Most Valuable Professional for developer technologies, specifically Python. However, Python is a very big language in machine learning and data science, which is a lot of what I do. So it gives me the excuse to touch on machine learning and also touch on Azure. I will tell you that the small amount of code that I have tonight, it actually is in Python, because Python is the dominant language and the one that Microsoft is putting most effort towards in the machine learning data science space. But it's nothing that nothing that will be difficult to understand. So I want to start off by doing just a brief overview of machine learning, how we got here, just a broad overview. Like I said, it doesn't really matter if you know anything about machine learning or if you're an experienced practitioner. There's going to be something in Azure for you. However, I want to go ahead and start off with a broad overview. So it started off with this field called artificial intelligence. And artificial intelligence, actually the idea, you could even think it's been around since the beginning of the 20th century, back with the Turing test. The term was probably formalized sometime around 1950s, 1960s. So it's still been around for a number of decades. And it sounds like it's a really, really lofty idea. We're going to build a brain out of Python or C# or something. But it turns out that the goal of artificial intelligence is not to mimic human intelligence. We don't know enough about human intelligence to mimic it in Python or anything else. Let me give you an example of what I mean, of kind of an early, simplified but early attempt at artificial intelligence. It's something called an expert system. And you basically, like I said, this is again simplified, but you had an expert and you had a programmer. And the expert, in this case, say that expert is an expert in the weather, a meteorologist. They would start to bare their intellectual soul. And they say, if the temperature is 32 degrees or less and there's precipitation, it's snowing. Okay. And the programmer would translate that into something that a computer could understand. So here, we have, this is actually Python here, but it should still be able to understand what it's doing. It's just saying that if the temperature, a variable named temperature, is less than or equal to 32, and there's a variable named precipitation that is equal to true, then it's going to be snowing, and otherwise it'll be raining. Now there's some errors with it. There's some omissions with this code and such, but still it's still the same. But the idea here is that what we're doing is we're basically giving this expert system a set of conditions, and it's returning back a forecast for the weather in this case. And a forecast is a prediction. So we could then begin to broadly say that the goal of artificial intelligence is to make predictions. We give a set of conditions or a set of, or a situation, and the artificial intelligence system, whatever we may call that, is going to make predictions based on that. And so if we go on now and present this artificial intelligence system to a user, the user could say something like, okay, the temperature is 28 degrees and there's precipitation. And based on what we saw on the previous slide, artificial intelligence system would respond, it's snowing. Now, there's something else that we have to consider here is what would the expert say? What would the human expert say? Well, the human expert, the meteorologist, would probably agree. So keep in mind, so now that we have the artificial intelligence system and the human expert agreeing, we can go ahead and expand our definition, or our goal is that the goal of artificial intelligence is to make predictions that mimic human response. So yes, we are trying to mimic human behavior. We're just doing it in a different way. If you've heard that the ends justify the means, that is actually no more true than it is with artificial intelligence. Let's go on now and let's get to machine learning. Now, machine learning is actually a subset of artificial intelligence. So if you actually look in the Azure documentation, they have all, there's the hundreds of services that they have. They categorize them, and they have for all the artificial intelligence, they say AI plus machine learning. That's kind of misleading because it kind of implies that they're two different things, and they are not. Artificial intelligence machine learning is actually a subset of artificial intelligence. Now, what makes machine learning different from artificial intelligence? Well, since it is a subset, the goal of machine learning is still to make predictions that mimic human response. However, we're trying to do that without being explicitly programmed. Remember that artificial intelligence, that very simplified expert system that we had, it was the rules were being written by a human. The rules were being hand coded, if you will. There are many problems with that. One of the problems is there can be things different in translation. I sometimes bring up the problem of, hey, what if the meteorologist is in the United States, but the programmer's in Europe? Well, the programmer's going to look at, say 32 degrees and snowing. That's a warm summer day, because 32 degrees Celsius, which is used in Europe, would be about 90 degrees Fahrenheit. It's also experts are expensive. Programmers can be slow, although we're constantly trying to work on that. Being able to get into the edge cases, could be of the subject matter could be difficult. So what we want to do is kind of flip this problem on its head and say we want a system that's going to discover the rules without being explicitly programmed. So that's what kind of machine learning does. So instead of asking an expert to give us all to give us all the goods, what we'll do is we'll start off with a data set. So here I have a data set that's with certain observations of weather data. It's fictitious, but at any rate, so based on the temperature, humidity, date, and location, we'll be able to see what forecast corresponds to that to those conditions. Now, a little terminology here. What we're doing is we're actually saying that the forecast depends upon the other four values. Now, in machine learning, we would call each of these columns a feature, and a feature is an interesting data point. It's something that and the features that we use to make the prediction, also called the independent variables, are referred to as a feature vector. So you can if you think of machine learning like a function, the feature vectors are the parameters or inputs to that function. The return value or output, the prediction, or what we're going to predict, is called a target. And this will come in handy later on when we start to look at some of the more involved services. So our goal is to have something that accepts a feature vector and returns and predicts, hopefully accurately, a target. So moving on, what we're going to do is we're going to give all of this to some kind of machine learning algorithm. In this case, it's going to be something called classification. And classification does more or less what it suggests. You have a number of what we would call labels or classes or categories or pigeonholes or whatever you want to think of. But however, there's a finite set, a well-known, a finite set of these. And in this case, they're going to be different forecasts. So we have rain and snow here. We could have clouds, we could have sun or whatever. But we want to create something that's going to take these, going to take values for these 4 feature vectors and return one of these classes or forecasts or labels or targets. And that thing is going to be called a model. Now the model is like the goal. Well, I don't want to say goal, but the product, I guess you could say, of machine learning. And the model is what we're going to pass new data to. So what we'll do is we'll give it data that's not in this data set and ask it to make a prediction about that new data. And that's what the model will do. And this process is called training a model. Now, more specifically, what you could say that a model is a representation of the knowledge in quotes, derived from analyzing data or analyzing training data. In reality, the model is just a big glob of numbers. You know, machine learning is nothing but math. There's an awful lot of math involved in training this model, and this big glob of numbers. These numbers are what we call weights, and these weights, as the training data goes through the as the feature vector goes through the model, the weights interact with it in order to produce that prediction. While training, what will happen is the model will constantly be the weights in the model will constantly be updated. With the goal of in the future producing more accurate predictions. So that's the difference between artificial intelligence and machine learning, or how machine learning differentiates itself from generalized artificial intelligence. You could also go further. You may have heard of deep learning. We're not going to go into deep learning really tonight, but I just put it in there because people have heard of it. Deep learning is a subset of machine learning. Deep learning is basically machine learning using neural networks. So if you've heard of TensorFlow, that's where you're going. This is good for more perceptive problems, such as vision and speech. And then you can even go further. Some people would say reinforcement learning, which is agent-based learning. That's for things like self-driving cars. I personally just consider it to be just to be part of deep learning, but at any rate, it is out there. And then some people also sometimes say, well, what about data science? Where does that come in? And I like to say that data science, it's related, but it's separate. Data science is more looking at things that happened in the past, whereas machine learning is looking at, or machine learning, artificial intelligence, and all these is more looking at trying to say what's going to happen in the future. Now, especially in the Python and R worlds, the libraries that are used in data science very much overlap. They're used often along with the libraries for machine learning. So things like NumPy, Pandas, Matplotlib, Jupyter Notebooks. We'll see Jupyter Notebooks tonight. That they are still used alongside of scikit-learn and TensorFlow and PyTorch, and what else is out there? What's the one that Amazon uses? I'm drawing a blank from the Apache project. MXNet, and Microsoft has one also called the Microsoft Cognitive Toolkit. So that's sort of a broad overview of how of the process of machine learning and how to differentiate the different types of machine learning and artificial intelligence from each other. But what can we do with it? Well, we already saw classification. This is what's called a type of supervised learning. In supervised learning, you prime the pump. You tell the algorithm, hey, this is what's interesting. So in the case of classification, we're saying we want you to classify, we want you to predict a class of weather or a forecast. It's also regression. Now, regression is also supervised learning, but what's different is the characteristics of the target variable. So whereas classification, like I said, there's a finite number of labels that you're going to predict from. Regression, the target variable is continuous within a range of values. So this would be something like predicting stock prices. We'll actually see an example of predicting home prices later on. Clustering. This is something that's called unsupervised learning. An example of what's called unsupervised learning. Like I said, with supervised learning, you tell the algorithm, you tell the model, hey, this is what I'm interested in you predicting. Clustering, you just give it the data, and say, you find out what's interesting, find out what the commonalities and associations are, and put in or what the groups are of common interest or associations. There's also recommendation engines. Everybody's seen these, Amazon.com, Netflix. They look at, Netflix looks at, hey, this is what you've watched. You watched this movie and all these other people watched this movie and here's what they watched. You might be interested in watching this as well. So recommending products or services based on people who share people who share the services that you're interested in. Anomaly detection. There's an old Sesame Street skit called which one of these things is not like the others? And that's exactly what anomaly detection does. It looks for the outliers. It looks for, what doesn't fit. So thinking, so if you're monitoring sensors, sensor readings, and you have one that spikes or something, a value that's out of range, something that might detect something that might indicate a flaw or something that needs maintenance. And there are other things also that can be done with machine learning. These are just some of the more popular ones. Okay, so 20 minutes in, let's finally talk about Azure. What does Azure bring to the table? So first of all, like I said, the model is the model is what you're aiming for. Without a good model, everything else is pointless. And Azure actually offers you a number of pre-trained models. Very well trained models. Everything I'm going to look at tonight is very small for reasons of time and space and such, but a well-trained model is actually going to your data set. It's going to have millions or even billions of training examples. And these things can take days to train and use, and use huge supercomputers and everything. And most of us don't have those kinds of resources at our disposal, even in the cloud. But companies like Microsoft do, and they have taken some of the more common situations and trained models on those, and they've exposed them and made them available through Azure. Now, like I just said, training a model also, and talk about also with the pre-trained models. Once you've got a model, you've got to maintain that, you've got to host it, you've got to security and things, and that's also something that's provided that you don't have to mess with that first example. Now, when I'm talking about managed compute, this tool, Azure Machine Learning, Azure Machine Learning Studio that we'll see, is written for data scientists and machine learning engineers. It's not written for cloud architects or developers or administrators or anything. However, like I just said, training these models takes a lot of compute power sometimes. So what Azure Machine Learning makes it easy to do is stand up compute instances or compute clusters for training or inference or deployment of a model, and makes it just a couple of clicks, and also taking them down as well with GPUs. Now, the reason that GPUs are important is because GPUs are basically they're number crunching devices. We generally think of them as associated with games or visualization, but it turns out that they don't care if the numbers that they're crunching represent a model in a 3D model of a hero in a video game, or a model in a machine learning task. So the GPUs can greatly accelerate machine learning tasks. Automated model selection. Now, this is something, like I said, again, there are different levels of entry into machine learning with Azure. Automated model selection is one that's definitely evolving. So in this case, what you do is you take your data set, that training data set that you're going to use to train a model, and you just upload it to Azure. You tell Azure, okay, this is a classification problem or a regression problem or whatever. You tell it, this is my target variable, press a button, and Azure will try a whole bunch of different models on it. And it will select, and then it will rank them. And then you can either deploy those models, or you can download them and use them in other applications. So that's a way to get into machine learning with Azure without knowing a whole lot, without knowing just the smallest amount of machine learning. If you need a little more control, but you don't really want to get into you don't want to get into any code specific libraries, there's an editor. It's a drag and drop visual editor for configuring machine learning experiments. An experiment is basically a project or a task. You can think of it like inside of an Azure Machine Learning workspace. And what's really nice about this is you have control over all things like the hyperparameters, algorithm selection, data preparation. I'll show you a demo of this. It's probably the most exciting demo of the presentation. But then you can automatically operationalize deploy to a web service directly from the editor. Jupyter Notebooks. This is also really cool. If you've ever worked with the F12 developer tools inside of Edge, the JavaScript console, and you've seen how you don't have to write a whole file of code and then submit it all at once to be executed, how you can kind of line, not necessarily line by line, but definitely in smaller chunks. Jupyter Notebooks does this. Started off as an offshoot of the Python, but basically it's running some kind of language server on a remote server, and then you have a web-based interface through the browser that allows you to access it. And what's really nice is all of everything that you do is persisted. You can share these between you can share these with people. You can actually they're just plain text, so you can put them up on GitHub and pull requests. They're kind of like interactive textbooks in some cases. So at many Python conferences, like I said, I do a deep learning workshop, and what I'll do is, instead of having everybody make sure they've got all this stuff configured, I just put everything in Jupyter Notebooks, and they go online and run the notebooks online, and so there's no setup. At any rate, I'll show you an example of those. That's pretty much all I'm going to have time to demo, but I do want to talk about a few other things that's offered. First of all, this thing called MLOps. This is actually worthy of a multi-day workshop in itself. But MLOps is basically DevOps applied to machine learning. As machine learning projects become more complex and are integrated with larger and larger applications, we found that we can use principles of DevOps, say version control, continuous integration, continuous development, and such. We can apply those to the machine learning lifecycle as well. So that, like I said, that's something that's worthy of but it's something that's supported by Microsoft, by Azure Machine Learning, and operational machine learning is actually supposed to be potentially one of the big pushes for 2021. It's all Azure, so naturally you're going to integrate with other Azure services, so like data lakes and data factories and such. There are also some other services that I'll talk about after the demos, kind of where can you go from here type of thing. VS Code support. Now you can do it. Now most of your work, a lot of your work, you can do inside of the browser, inside of Azure Machine Learning Studio. However, when you get down to the lower level, more code-oriented projects or experiments, you're going to want to have an actual editor. And so there's an extension for Visual Studio Code that will allow you to interact with your Azure Machine Learning resources from the editor, so you don't have to go back and switching back and forth. There are SDKs for Python and R. Python and R are the two dominant languages in data science and machine learning. Like I said, Microsoft seems to be pushing most of their emphasis towards Python. For greenfield projects, definitely Python is where everything's going. R does a great job, but R does one thing and one thing only. It's basically data science. That's all it does. Python is a more general language. It's also much more friendly. And also, if you want to manage things from the command line, of course, the Azure command line interface, there's an extension for Azure Machine Learning as well. All right, so let's talk about this first, about the easiest way to get into machine learning with Azure, and that's going to be the Azure Cognitive Services. And this is something that people probably have seen already, but I do want to go ahead and mention it. This is those pre-trained models I was talking about. Those pre-trained models, that take days to train. And then also you have to maintain, you have to host these, and most of us don't have the resources for that, but Microsoft does. So what Microsoft does is they expose these models through a REST API. And everybody knows REST, and there are also SDKs. So I'll be talking about the SDK. I'll show you some examples of the SDK for Python tonight, but there are also SDKs for C# and Java, JavaScript. There may even be a Ruby SDK hanging around out there. And these are for common patterns or situations or problems in machine learning. For example, sentiment analysis. This is something that comes up all the time. You throw a piece of text at Azure, and it gives you a value that represents whether this is positive or negative sentiment. Object detection. Does this picture have a hot dog in it or not? We already saw anomaly detection. Finding things that don't fit in, and even more things like text to speech. So being able to take a piece of text and it'll generate audio either in a file or streaming that will be an almost human-like voice or almost human-like artificial voice. And there are many others. I think there are 17 total services, and there are even more tasks that you can. So, for example, sentiment analysis is part of the text analytics service, which has about a half dozen or so different tasks that it addresses. Now, the way that this works is you either call the REST API or you make a request using the API of the SDK. You toss your data up on, for example, sentiment analysis. You send it some text. Microsoft will do some machine learning magic against the model, charge you a little bit of money. And when I mean little bit, literally, sometimes it's as low as fractions of a penny per transaction / prediction. And there are even free quotas to get started. Everything I'm going to do tonight is on a free instance. And then they'll send you the results back either in JSON if you're using the raw REST API, the bare REST API, or it'll be in some kind of an object if you're using the SDKs. Now, these Azure Cognitive Services, if you're an application developer who knows nothing about machine learning, this is where you should go first. This will cover a majority of your needs. I need sentiment analysis. I need object detection. I need to generate some audio for a piece of text. This is where you're going to go first off. So, without any further ado, let's take a look at how this works. So, like I said, I'm using Python here. Actually, what I should do first, I should go into the Azure portal instead and show you how you might create one of the things. So, the anomaly detector. What I'm going to use is just an example here to. I'm not going to actually spin one of these up. Okay, what kind of mood is Azure in this evening? All right. But I thought I told it anomaly detector. There we go. So not a lot of decisions to make. Select a resource group. Let's see here. What have I got here? Select a region. Things that you've seen before. Demo. And then what you'll do is you'll create demo DAS 2021. Thank you. Okay. And then you'll select a pricing tier. Like I said here, the pricing tier, they're basically free. They're free tiers for almost all of them. And while you can't run anything in production off of them, because first of all, the SLA, there's no production SLA, you can definitely play around with it and see what's going on. At this point, I would, of course, go ahead and create it, but instead, I will go to one of the ones that I've already created. So I'll go to the text service. Let's see here, text analytics. There we go. And I should have one of these already. There we go. And one of the things that you'll need to do is you'll need to take note of whether you're using the API or whether you're using the bare API or you're working with the SDKs. You'll need to take note of one of these keys and the endpoint. This key will be provided. This key basically identifies your subscription. So that's all we need to look at there. And there, let's go over to some code now. So for purposes of security, because like I said, I know some people in Nashville, and I didn't know if they were going to show up tonight, so I'm not going to put my keys out there for the world to see. That's a joke. My friends in Nashville are wonderful people. Everybody in Nashville is wonderful people. But however, I still got them in there. So, but looking at this text service, and if these look familiar, if you go later looking through the documentation, some of this looks familiar. Yes, these are modified examples that I got off of Microsoft's documentation, just because they're easy. They're general purpose, easy examples. But just bring in some packages from the SDK. Here, authenticating a client, you'll need to have a client to access everything. Here's where my key and my endpoint are being used. And then down here, create a client, and then the actual work. This is all that's needed to do the actual work. Simply call a method and pass it the documents. And a document is a piece of text, and a document can have multiple sentences. So it doesn't have to. So that document, it's like I said, it's just a body of text. And what'll come back from that, you'll get a sentiment, and a sentiment is either positive, negative, or neutral, and that's the overall sentiment. But however, what will happen is you'll rarely, except in some simple cases that we actually will see, you will never be absolutely sure that it's 100% positive, 100% neutral, or 100% negative. Even when it says that it's 100% positive, because the numbers are being formatted, it's actually probably something like 99.9999999. It rounds it up. But however, it will give you a score for each of the possibilities, positive, neutral, or negative. So it might be like 92% positive, 6% negative, and 2% neutral, and that all adds up to 100. And it'll also do the same for each of the sentences. So what I've got down here is I'm just simply passing in on the command line. I'm passing a piece of text. So here, let's see here. Let's toggle the word wrap because of resolution. So I just grabbed these off of the review site. And this is saying IMDb is a perfect database for film, the perfect scoring system, incredibly reliable, friendly user interface. This looks like it's probably going to have a positive sentiment. So if I do Python text.py, has it demo1, and run, this is what we'll get back. So we'll see that overall, the document sentiment is positive. And I think most people would agree with that. And but notice that again, it's going to give me a score for each possibility. So positive, it was 98% sure that it's positive, 2% sure that it's negative, 2% sure that it's neutral, I'm sorry, and it doesn't think it's negative at all. And then it goes through and does the same thing for each of the sentences. This is actually a case in which it claims to be completely sure that it's positive, but in reality, it's more like 99.9999999. And then this one down here is an example of where it's a little more varied in the score. Look at this one here. This one is going. Why doesn't it keep my word grabbing? However, this one devolved into this modern useless thing, useless stuff. Let's see here. It's stripped out. The app is even worse. So site has been in constant decline. This sounds like it's going to be pretty negative. And if we look at that, this has got more sentences in it. If we go up here, we'll see that yes, it is. It's pretty sure that it's negative, 12% sure that it's neutral. And then for each of the sentences, here's a sentence. Here's a sentence that's more neutral than anything else. There's some of them down here there's one that I was really surprised about when I ran this. Which one was it? Yeah, this one right here. It says this site has been on a constant decline with no end other than the end in sight. It said this one was neutral. I was kind of surprised by that one. But at any rate, that is, but you can see, I guess, hopefully you can see how easy it is to get this functionality. And you could integrate this into your own app fairly easily. So like I said, there's an SDK for .NET. So you could have a Xamarin application, and you could take a picture. You could take a picture using the camera, upload it to Azure, tell Azure, hey, what objects do you see in this? What objects do you see in this image? And it would return, and it would give you a list of them. You could say, you know, is there a hot dog in the list, or whatever. And it's very, very easy. And you don't have to know anything about machine learning to do it. Take a look at one more example here. This is actually the computer vision service. Starts off very, very similarly. You have to create a client, but it's a simple method call. Just this one simple method call. I've got some images here from Unsplash that I'm going to pass the URL to, and Azure will pick them up, and then it'll give me some information about captions. So this would be automatic captioning is what it is, and then how sure it is of that caption. So let's take a look here if I can get back to my browser. And this is a picture. It looks like coffee is involved in this picture. So let's go back to Visual Studio Code, and let's say Python CVPy, and see what it says. And it says a person holding a cup, and the confidence isn't that high, but it is correct. You know, you look over here, you see a cup, you see two cups, and you see this hand. Azure isn't sure whether that's an actual person, or whether it's a mannequin, or whether it's a humanoid robot of some kind, but it did get that part correct. And you notice that the word coffee actually is in the picture twice. There is also an OCR service, or an OCR task, I guess you would say, within the computer vision service that can actually recognize text in images and such. But at any rate, that wasn't too bad. Let's take a look instead. Let's take a look at this one down here and see what it can do with it. This one looks like a picture of a window. So save that. And it says a window on a building. It's a little more confident. So like I said, there's a whole lot more that you can do with this, but it's basically variations on the same theme. You get your credentials, you create a client, you call a method on the client, and you do something with the results. That's basically what it is. So everything else is in the documentation. Like I said, there's much more that you can do with this. However, in the meantime, let's go on and get back to some slides and start from the current slide. Okay. Now Azure Cognitive Services, like I said, it's going to cover a majority of the situations, but there are some situations in which you might not want to use it. One of those might be sensitive data that cannot be used in the cloud, or cannot be used with this particular service that Azure offers. It may be able to be used in other services within Azure, but the one that's probably going to come up, more often would be, or one that would be more applicable to the talk, would be proprietary data, say industry specific terminology that the generalized models that Microsoft has trained for you don't know about. And these models are pretty much static that are in Azure Cognitive Services. There is one exception. It's called the Custom Vision Service. And you can actually upload images to the Custom Vision Service, and it will extend or augment, conceptually extend or augment the model, the vision model that's already been trained, something called transfer learning. So, but think about this. What if you're doing text analytics on something that uses industry-specific terminology? You cannot, there's no way to extend the text analytics service with that. So you would need to have a custom trained model. And that's when you would start to get into the Azure Machine Learning Service, Azure Machine Learning Studio, Azure Machine Learning. They all refer to basically the same thing. I will say that the Azure Machine Learning Studio now refers to the web interface for the Azure Machine Learning Service, which you access your workspace and all your compute resources and notebooks and everything that we'll see in a minute. There is actually a product called Azure Machine Learning Studio Classic. And this was the original implementation. It's actually the first of these products that Microsoft put out. I believe it's still around. I believe it's still accessible and free. But that was actually my first exposure back in, about 6 years, 5-6 years ago to machine learning. But like I said, the Azure Machine Learning Studio now, when I'm talking about it, refers to this product that we'll see later on. Azure Machine Learning, basically, here's kind of a marketing blurb. Azure Machine Learning and I just noticed something. Have I been ignoring the chat? I don't even know if I can get to the chat. It won't let me. Bill, if there's something in the chat that I need to know about, please feel free to interrupt me. Come here, chat.
There was just one question, I think. In the chat.
Okay. Let me see here.
I'll keep an eye on it.
Okay. Let me see here. You do not .NET program test to learn Python to do anything. And no. I will say that there is a lot of that there are some things that can only be done in Python. .NET, like I said, the Azure Cognitive Services obviously are going. There's a .NET SDK. Deployed models that you create within Azure Machine Learning. Those will be deployed to a REST API as well, or a REST endpoint as well, so you can access those. There are some things, however, like the Jupyter notebooks, they work with Python and R. So let's see here. You mentioned drag and drop experiment editor. So I think they may call it the drag and drop designer. It's actually within. You have to create a workspace, and I'll show you that, and I'll show you that in just a second. You don't have to do. You do. Yes, and there is ML.NET. Actually, my version of this talk for .NET is actually about ML.NET. In fact, I'm doing that twice next month. Now, ML.NET is not specifically support. It's a machine learning framework that for .NET that Microsoft offers, and there are ways that you can interoperate. So, for example, you can train a model in ML.NET and bring it into Azure, and vice versa. You can train a model in Azure Machine Learning and pull it out put it into ML.NET. But Python is definitely the dominant language in this space. It's definitely the gaining language. R may still have a little bit of an edge over it, but definitely the up and coming one is Python. Okay, so machine learning at scale for enterprise level applications. So basically, we're talking about really big stuff here. Like I said, there are many. Come on. There are a number of entry points, and the automated machine learning, drag and drop designer. That's actually, I probably should have put drag and drop editor designer on the previous slide, and the Jupyter notebooks. And that's what we're going to look at now. This stuff, I could show you slides about it, but it's easier just to show you. So I will say one thing about these demos. This is not a service that is meant to be babysat and watched. So the demos are basically going to be like, okay, I'm going to configure something. Here's what you do to set it up. And then we're going to fast forward because I've already got one that's done, and all the stuff in between is basically just waiting on models to train and compute instances to deploy and spin up and things. Oops, that's not what we weren't ready for that yet. Okay, you didn't see that. All right, so let's see here. Let me go back over. So everything in what you're going to do is you're going to want to create a machine learning workspace. And a workspace, you can think of it conceptually, it's kind of like a special purpose resource group that's only for Azure Machine Learning resources. But oops, I want to create a new one, start to create a new one. Not a lot of decisions to make. A resource group, a name for it, and a region. So not a lot of decisions to make. When you get one, there's not a whole lot that you can do with it inside of the portal. Instead, what you want to do is you want to work inside of Azure Machine Learning Studio. Like I said, this is where you build, train, evaluate, deploy your models. So if I launch that, I can also go to ml.azure.com and I'll be able to choose a workspace. Now this workspace is one that I stood up earlier today for the demos. And this is where you do most of your work. Like I said, you can do some things in Visual Studio Code if you want to go with a more code oriented approach, but the higher level things such as the designer and the and automated machine learning, you're going to want to do mostly from in here. So the best place to start, you're going to need data. So number of data sets. So what I have here is these are some data sets up here that were trained through the designer or created through the designer earlier today. But I have this one that I created here earlier today. And if I go to explore and I look at this data, this is actually what's called the Boston housing data set. It's a very, very popular introductory machine learning data set. And what we have is data about different houses in the city of Boston. And so you've got things like the crime rate, and let's see here, the number of rooms, the age of the house, the property taxes that you have to pay, and then you have the price over here in thousands of dollars. Or actually, it's hundreds of thousands of dollars. I'm sorry. And I think this data set's is aged, so these prices are probably not $2021. But at any rate, so what we're wanting to do is, in this case, this would be a regression task because our target variable is a continuous value within, of course, a specific range. I would assume anywhere from 0 up to millions. But there are 14 columns or features, and the first 13 are going to be our feature vector, and the last one is going to be our target value. So that's one of the data sets that we have that we can work with. The way that I got this, I'll show you the notebook that I used to generate it later. But all I did was simply uploaded a CSV file, comma separated value file from my local machine. Now you can also pull these in from a web URL. That's actually what I do generally for this talk, is I pulled them in from the University of California, Irvine machine learning repository. However, this morning that site was having a bad day, and so I had to improvise a little bit. There are also some data sets that Azure provides for you, and then from a data store that would probably be that'd be like an Azure data source or something. Also, what we need is compute, and so there's a tab down here for our compute resources. We'll get to compute instances in just a minute. Compute clusters, this is where you're going to do most of your training. Again, like I said, creating one of these, just drop dead simple. The region is going to be defined by the workspace. You can choose dedicated, which is going to mean there's going to be one available for you when you need it. It may not be running immediately. You may have to wait for it to spin up. Low priority, that would be one that can be preempted. Virtual machine type, then I talked about the difference between CPUs and GPUs. You select the size here, so I'm just going to use the one. So this one here is what they recommend off the top 4 cores, 14 gigs of memory, and then you would give it a name, and you give it a minimum and maximum number of nodes. Obviously, the more nodes, the more instances, the more training you're going to be able to do at one time. Minimum number of nodes, what will happen is these, once they're idle for by default 120 seconds, they'll be deallocated or stopped or taken or deprovisioned or whatever. However, you won't be charged for them. But the problem is, if once you start to start an experiment or start training or something that's associated with this cluster, if there are not a sufficient number of nodes running, you'll have to wait for them to spin up. So what you could do is you could change the number and have a certain number of nodes running all the time. However, I'm not going to do that because I've already got this one here. And this one has, where is it? It should say somewhere that I've got 4 nodes. Yeah, there we go. Maximum number of nodes 4. And after they're idle for 2 minutes, they'll scale down. With that, so those are the 2 pieces that we need to do automated machine learning. Now, I've already got one here that I'll show you in just a minute, but let's take a look at how to create a new one. So when you run, what I could do is I could pull in a data set, or I could use one that I've already got here. So I'll say I'm going to use that housing data set from before. An experiment, like I said, an experiment is basically a project or a workflow, and I could create a new one here. Got one already set up, and like I said, we're going to have to select the target column. In this case, we said the target column is price. Select a compute select a compute cluster. Oh, that should actually be not computer cluster, but compute cluster, but at any rate. And then you'll select the type of task. Now, right now, there are only 3 types of tasks supported. Classification, regression, which we already saw, and time series forecasting. That would be something, again, like stock values or something. Select regression, and then I would hit finish. I'm not going to do that because I already have this. This is done. I did this morning. So this ran for, on those 4 nodes, it ran for just a little more than half an hour. And here you can see all of the different models. And as you can see here, it's went through, it actually did about 30 different models. They took, some of them took as much as 3 minutes, but in general, they took about a minute. It's not a very big data set. It's only about 500 rows. Like I said, it's a toy data set. So from here, what I could do is I could select one of these. I could deploy it to an Azure Kubernetes cluster. I could download it, in which case it will give me a zip file with the with the model itself, a Python script to be able to integrate it into another application, and also an environment, also a YAML file that will allow me to spin up an environment in Anaconda, which is a data science and machine learning Python distribution from some folks in Austin. But other than that, at this point, it would be up. At this point, you would select which one of these you want and go forth and use it in some way. I'm not going to deploy it right now because we're going to see what a deployed model looks like in another context. What I'm going to go to now is I'm going to go over to the designer itself. Now, the designer. This is the drag and drop interface that that I was talking about earlier. So create one, simply create a blank one. I'll need to select a compute target for it. Select that cluster that I had before. And now what I can do is I can start to drag. I've got a whole bunch of modules over here. So I've got data sets. I got sample data sets. I've got the data sets that I loaded from this tab. I got ways to bring in data from, like it says here, web URLs or other Azure sources. Data transformation, things. This is preparing your data for the training process. And notice that there's actually, I think there's more. Oh well, the algorithms. But tied with the algorithms, there's more modules in here than any other one, and that's because preparing your data actually can be up to 80% of the workflow. Again, garbage in, garbage out. But this is things like removing missing data. It could be something as mundane as renaming columns, computed columns, computing new values from old ones. Lots of different things that can be done. And this is also where the data transformation, data preparation, also called data munging, is more than worthy of a multi-day workshop in its own right. Like I said, there's a number of algorithms here. We'll see that in a minute. There's another thing that you can do in here is you can actually, if there's not a module if you have a task and there's not a module that fits that task, then you can actually include Python and R scripts. Then there are tasks for text analytics, so things like word embeddings. And let's see here, there's the anomaly detection, recommendation, and so on. However, I'm going to just create a new one. So you just drag and drop your, whoops, in this resolution, it kind of dominates the screen, but at any rate, so this is my data set here. I can also interact with these. So for example, I could visualize this data set. Take a second. And what it will do is it'll show me the data set, show me all the values. It'll also show me some statistics about the about each feature. So for example, the number of rooms is pretty much a normal distribution. The price is pretty much a normal distribution as well. A little bit of a tail there, but and then what I'm going to want to do at this point, I would normally go through and do the preparation. I could run modules to do that. I'm not going to do that for this example because it's because I've got a lot of other stuff I want to go through. So what I'm going to go through next is I want to split the data, and I want to split it into a training and testing data set. Now we already saw what the training data set is for. It's for training the model. That's the data that will be analyzed to train the model. After the model is trained, what we'll want to do is we'll want to do want to test it or validate the performance of the model, and we're going to use part of the original data set for that. We'll feed the feature vectors in. We'll get the predictions that the model made, compare them to the ones that are actually in the data set, and then use that to create some metrics on how well the model is performing. But there is a split data module. I'll drag that over there. Now to get the data into the split data module, simply drag and drop. That easy. Notice that you can't mess it up. It will not allow me to drag. It'll not allow me to connect it where it doesn't belong. At this point, it's time to select an algorithm. This is a regression problem. So I can pull out the linear regression module. I need to train the model. This is going to accept, this needs two. This needs to have two connections. So the untrained model, which will be my algorithm, and then a data set, which I'm going to use the training data set. Now, one thing I forgot to do is the split data. One of the things I need to do is specify a split point. Right now, it's saying there could be 50-50. So 50 in the training data set, 50 in the testing data set. Generally, you want to use more like 70-30 or 80-20 split. For this such a small example, it probably doesn't matter. But at any rate, this is where you would do things like set your hyperparameters. And again, you do this with all without code. The train model, notice that there's this warning or error indicator of some kind, because the train model, this is where we're going to specify the label. This is where we're going to specify the target feature. Go over here, select edit column. It'll give me a list of the columns. Again, you want to select price. Well, we want to select price. At this point, I want to test the model, or as they say, score the model. This wants a trained model, which is what's going to come out of trained model. And then it's going to want a data set, and I'm going to select the other part of the other part of the data. And now what I need to do is see how well it worked, evaluate the model. Notice that there are two inputs here. So if I wanted to, I could train another model, and or what I could do is I could actually just pull another algorithm over here and use these same splits, reuse these other modules over here. But I'll leave it there for now. At this point, I would hit submit, and it would start to spin up. Well, I'll go ahead and hit submit so that you can see what's going to start. And this is going to take a while. I've already got one that's done. It's going to take a while because what it's doing, and we may not even be able to see it yet, but yeah, eventually I'm going to go on and show you the finished one, and we'll come back to this so you can see that it starts to spin up the nodes and such. So let's go back over here to the designer. I have one that I already created earlier. And here it is. You can see that everything is completed. Actually, I need to show you that. Hang on just a second. Where's my Snagit editor? This is what happens. This is what happens when you're during the training process. So what'll happen is it'll show you. Come on, let me zoom in. It'll show you the progress. It'll show you the different stages. So these over here are completed. You've got one that's running. These haven't started yet. got one that's finalized, that's just finalizing. Over here is same thing. Here's when it's queued up. So you'll be able to monitor the progress, or what you could also do is you can also watch the you can also go through and you can watch the runs in the compute instances. We'll see some of that in a minute. At any rate, this one's already done, and at this point, I can go down here to the evaluate node, right click on it, visualize the evaluation results. And this one's not going to be actually too exciting. This one could be better. This is kind of the number that we're looking for here. We want this to be as close to 1 as possible. But at any rate, that's how we could see the results. Let's take a look at one that's maybe a little more interesting. And this is actually one of the samples that Microsoft gives. This is a binary classification example. It's interesting is that in machine learning, we separate binary classification and multi-class classification. So binary classification, binary meaning two, one thing or the other. In this case, what we are trying to predict is we are trying to predict based on all of these features such as education and occupation and race, sex, number of hours per week worked, whether or not a person's income is below or above $50,000 a year. And so again, this is binary classification. It's either below or equal to 50,000 or above 50,000. This would be in contrast to a multi-class classification problem that has more than two. So even though two is more than one, multi-class classification in machine learning means more than two, actually. Again, I've already trained this one. We'll go down here and we'll look at the score model and we'll visualize this output. So this is this is classification. Oops, that's not what I wanted. I want the evaluate, sorry. When I was going through this stuff earlier today, I was not looking at the screen at this resolution. So, but anyway, we see some additional output here. This one right here is kind of the at a glance. This is what's called a confusion matrix, and it's aptly named because it shows where the model got confused, where it flipped when it should have flopped. If you had a multi-class, so for binary, you only have two instances. But normally what you would have is for each class, you would have a row and a column, and you would have a diagonal along here. So along one axis, you're going to have the actual values that were in the training data or in the testing data set, I guess. And then here you would have the values that were predicted by the model. And down the diagonal, those would be when the predicted and actual when the predicted and actual values matched. And so what you would want to see is a nice dark line down that diagonal. Now it's not really as obvious here because we've only got two, but what you can see here is that 11,728 times it predicted that a person's income was below less than or equal to $50,000, and that was correct. However, 670 times it got that wrong. There's also some other statistics over here that we can work with. So for example, the accuracy. This is basically saying how many predictions were correct versus the total number of predictions is a simple ratio. So about 85% correct, not too bad, but could definitely be better. The thing about accuracy is it's not necessarily the best metric, because you could say, okay, what if you have 100 predictions and 99 of them are correct? Or not, or at least let me put it this way: 99 of them have a particular value that you're looking for. You know, say that 99 of them are below or equal to $50,000, and only one is over $50,000. Well, you could make a really dumb model, and all it does is no matter what, it predicts less than or equal to $50,000, and it's going to be 99% accurate. So so this is useful, but sometimes you want some more nuanced methods. So this precision and recall. So precision, these are easy to get mixed up, but precision basically says how many of the positive predictions, meaning in this case, the above 50K were actually correct. So you're going to take, and then this one here, this recall, this is one that says out of all of the actual positive predictions, how many were correct. So there's sort of a little bit nuanced. Of course, this one definitely could be better here. This F1 score is basically a combination of these two here. Not going to get into it too much. So I do want to talk about is this thing here, the ROC curve. Now this stands for receiver operating characteristic. It's actually something that comes out of Sonar. I don't know how it came out of Sonar, it's just what I've heard. But as you can see down here, it represents the true positive rate versus false positive rate. And we obviously want this to be as high as possible. Ideally, what we would want is we would want just a nice straight line up here, meaning that all we were able to recognize were that we got all the true positives correct. That's, of course, like I said, rarely going to be the case. But what we do want to, but the way that we can interpret this is by looking at the area under this curve here. And obviously here, a vast majority of the area of this graph is under the curve. And that's what's represented by this AUC, or area under curve. About 90% of the area is under the curve. So again, not too bad. Let's take a look at our compute instances over here. And you'll see that, what? Did I forget to do something? That's the thing about live coding. Oh, okay. I actually did not anticipate this. Let's see here. Okay, so what happened was, since I had run this before, it just reused everything. That's what that little recycle icon means. It just reused everything. So what I'm going to do is I'm actually going to force this to do. I'm going to use a different regression module. Hold it. Here, come on. Give me my algorithms. Let's see here. Let's use the two. Where's the two? Here we go. Decision. It doesn't matter. I'm just trying to force it to make a change. Okay, now let's do it. Okay. And we'll continue to look at some other things and come back to this in a minute. All right. Sorry about that. Okay, so let's go back to I want to go back to the housing one, because this one works a little bit better. Okay, after you would, okay, so you've trained the model, but now what you need is a way to actually use it or make inferences. And for that, what you would do is you would create an inference pipeline, which is basically a new project in the experiment. And you can create two. A real-time inference pipeline in which you pass a single feature vector to it, and it gives you back a single prediction, or batch in which you pass it multiple and gives you back multiples. This also requires time on the training cluster, so I've already got one made up here, and this is what it looks like. And notice that it's much simpler. It's got our trained data set that's being combined with a web service input. This is going to be deployed to a web service. It's going to give us an output again as a web service. At this point, what I would do is I could hit deploy, and it would ask me for the name of a Kubernetes cluster, because these are deployed in production onto Kubernetes clusters. So I've got my compute tab over here. Is this thing not? There we go. You can see it's starting to spin up now. So what I would have is I would create an inference cluster. These are Kubernetes clusters. Very similar idea to before. You simply choose a region and a size. Need to give it a name. Here's the big thing that you need to know about this for production. You have to have at least 12 cores. So this machine has the size I picked has 4 cores, so you would need to have at least 3 nodes. Not a whole lot to say there. Once it's deployed, you will see you'll see an endpoint come up over here, and this is the endpoint that I created earlier today, and get some various statistics about it. What you'll be interested in actually, the test and consume. Now the test, what I could do is I could just pump values in here, hit test, and it will give me a prediction. In this case, it's giving me a prediction of $290,000 for this particular house, which is actually $240,000. And then I could mess with these values and get different predictions over here. Consume is actually how you would actually use this in an application. So there are a couple of ways you can do this. I'm going to use the key tonight. This is a key that we passed into the headers, and it'll give you some sample code in C#, Python, and R. Now I'm going to run the code in R in just a minute, but first of all, I want to go back and check on this pipeline here. Okay, here you go. You can see that the pipeline, you can see that this is running. This one is reusing this one because it already did it before. And if I go back to my compute tab, I should be able to see, yeah, that this one now has spun up one of the 4 nodes, and it's running, and there's all the different states. Okay. So, all right, Line is that? I'm sorry for mispronouncing your name. Watching this later, thanks for coming. I appreciate it. Okay, so that's part of the designer. We'll get to the rest of the designer where we actually use the deployed model here in just a minute. I want to go through and look at the notebooks. So first of all, notebooks are going to need compute resources. Going to need one of these compute instances over here. I've already got one made because it does take a few minutes to spin one up, but take a look over here. Again, pretty much the same options. Notice that if you select GPU, notice over here the cost that we've got over here. The most expensive one is 37 cents an hour. GPUs, this recommended one here is little more than twice the most expensive recommended option. And this is actually the K series, the Kepler class, is actually a pretty puny CPU, pretty puny GPU by today's standards. They're good. There's nothing wrong with them. They're not flawed or anything. They're just kind of old. But if you take a look at all of the options, you can see that you can get you can actually get, you know, $13 an hour. It's for the most. I think that's or close to the state of the art. But at any rate, I've already got one of these, and notice that there are several options here that I can interact with it via Jupyter Lab or Jupyter RStudio or the terminal. RStudio would be for R, Jupyter Lab and Jupyter are for Python or Jupyter. Now, if I click on one of these, it's going to open up an interface for the actual Jupyter Notebook project, the interface. But what I'm going to do instead is I'm going to go over here to my notebooks and create a new one. And what can I just call it demo. And what you'll see is it's attached to a compute instance. And that's what's running on the back end. That's what's running that server, which in this case is Python. I could also get R if I wanted to. Now what I can do is I can begin to put Python code into these cells and run them. And I can create new cells. So I could do something, you know, for, I don't know, in range 10. Yeah, come on. Print. Something like this. Well, you know, and what will happen is we will be able to, and maybe I want to go back up here later and say, hey, I want to do 20 instead. All I have to do is go back up to that, cell and modify it. The other nice thing about these is that I could, can download these. I can upload these to GitHub. In fact, let's take a look at what happens when you upload a Jupyter Notebook to GitHub. I'm going to see here. Let's see here. Oh, there's one. So these IPYNB files, what happens when you upload these to GitHub is it renders them statically. Now you can't interact with them this way, but you could download them and upload them to Jupyter Notebook. But as you can see, these can be quite rich. So I've got some images in here and text, and then somewhere, theoretically down here, there would be some code. There's some code, and I would be, if I was running this live, I would be able to execute this code, modify this code, add my own. Like I said, these are actually just plain text. It's actually JSON in the background, so you can upload these and to GitHub do pull requests. These images, where was that image up there? these images, they're actually base64 encoding these images and just putting them in text inside of the JSON. So this is what's called reproducible research. And it's very, it's a very big problem in machine learning. But the other thing that's nice about this is it allows machine learning practitioners. Yes, Brandon, you can run notebooks locally. You can download Jupyter Notebook and install it on your machine. You can also run Jupyter Notebook inside of Visual Studio Code. That's actually the way that I prefer to do it. So yes, you absolutely can run notebooks locally. Just install Jupyter Notebook. And like I said, also through Visual Studio Code as well. And actually, and another thing that is this works with the insider build, but there was a little bit of a discussion of ML.NET earlier. You can actually there's a .NET interactive that runs inside of notebooks inside of Visual Studio Code. Like I said, I believe you have to have the insiders build to get that to work. That's how I've been using it. But and then you can work with ML.NET inside of notebooks, which is really awesome. Okay, but here is, so for example, let's see here. So there are a number of sample notebooks that you've got over here. So for example, this is one that's a little bit more interesting. But like I said, this is a notebook that I did not make. However, I can just download it, start interacting with it. Start interacting with it immediately. So, and some of the other things that you get with the notebooks are, for example, you still get things like syntax highlighting, code completion. You get docstring. This is basically inline documentation for Python code. And then of course, you can also put markdown cells in here. So what would it be? You could do text, shift enter, renders the cell. But what I used this for earlier today was, like I said, when I saw that the UCI machine learning repository was having a bad day, I said, okay, I'll switch back to the Boston Housing data set. And the Boston Housing data set is actually inside of scikit-learn, which is another machine learning package for Python. So I went through and I pulled and I got the data set out, and here's all the data that's in there, and used pandas, which is a data analytics package for Python. Also mimics a lot of functionality in R. To load that data in, combine the features with combine the feature vector with the targets, which is what I'm doing right here, and then let's see here, write that out to a comma separated value file. And in fact, I could go ahead and, well, I'm gonna have to run the whole thing. Cell operations, run all cells. But what will happen is when we get down here to the bottom, do it. If I refresh over here, you'll see that it's created that new CSV file, which I was then able to download to my machine and then upload to Azure Machine Learning. So these are useful for all kinds. These are used for all kinds of things. Also, when you get into visualizations, you can render visualizations in line with Jupyter notebooks. All kinds of like I said, all kinds of crazy stuff that you can do. And like I said, you can get they add some different things in here. If you've got Markdown, and if your Markdown is structured correctly, you would actually be able to do bookmarks and things over here. So let's see here. What else do I want to show? Okay, so let's go over now here to this one that I had earlier. And oh no, what did I do? There we go. And there are also a lot of keyboard shortcuts that you can use to navigate these. You don't have to use the mouse. Let's see here. What did I want to do? Okay, I wanted to go over to my code here for R. Just copy this, paste it in here. And this is just Python code that's going to set up my key and my endpoint, make the HTTP request, get the response, and spit it out in JSON. And then here are all my features and the values that I want to pass in. This one, I only have to have it. It's actually being ignored, but I have to have it in order for this to work. So if I run this cell, canceled. Well, no, there we go. You'll see down here that what I'm interested in right here is the scored labels. And again, like it was earlier, it's predicting a price of about almost $300,000. Just to show you there's nothing up my sleeve, if I increase the number of rooms here to 10 and run that again, you're going to see that, come on. There we go. It's in the price has increased. So that's another tool. So that, like I said, those are the three main tools that you'll use in here, and you get to everything, all of your models, all of your endpoints, all of your compute resources. Still, the training has finished now, so it's resizing down from 1 to 0 nodes. Now this data labeling, this is something. Oh, I thought this was in preview. It's not in preview, but anyway, this one here I didn't. I'm just going to mention it because it's something that actually comes up quite a bit. If you're working with image classification, what you have to have is a whole bunch of images that are labeled, and doing this by hand can be really tedious. This is a tool that allows you to upload all of your images and label them in mass, basically. So it makes things a lot easier. All right, so that's pretty much everything I wanted to show you in there. Let's go back to the slides. And yeah, I've been talking for 90 minutes. So let me just say a few more things, and I will then wrap up and get out of your hair for the evening. So where do we go from here? There are some services that are not strictly machine learning services, but they are very relevant to Azure. So one of them is the Azure Bot service. Now, this is not a machine learning service, but it often leverages machine learning. So it's actually a communications framework for interactive agents, and we call those chatbots sometimes. In fact, the tutorial for the Azure Bot service, what it does is it merely, it defines things like prompts and dialogues and cards that visualize data and things. But what it does is it shows you how to prompt a user for a location, a zip code, or a city or whatever. And then what it will do is it'll go out and it'll make an HTTP request to the Open Weather Maps API, and it will return a weather forecast in, I've got weather forecasts on the mind tonight, but I will return a weather forecast and show it in a nice little card. Is that useful? Yes. Does it use machine learning? No. But many times you will use something like the Azure Cognitive Services, or maybe an endpoint that you've deployed to a Kubernetes cluster via the machine learning service or something like that. Azure Databricks. This is this is a analytics service for big data. If you've ever heard of Apache Spark, it's basically a managed, nicely packaged version of Apache Spark. It's not just for machine learning, but there are machine learning modules and functionality for it. The mlib package for Python, and then it also uses R and Scala, which is a Java-based language, is big in Databricks. Finally, this last one, the Power Platform. If you're not familiar with the Power Platform, I would recommend that you become familiar with it. You don't have to be an expert in it or anything, but you need to know what it is. It's for something that's called the citizen developer. And basically it's allowing, taking a lot of I don't want to say the grunt work, but a lot of the common tasks that knowledge workers or people outside that would need, that normally they would ask IT to accomplish for them. And it allows them to accomplish those apps themselves. So Power BI, self-service analytics, Power Apps is actually application development, mobile applications, and then also through the web. I don't think you can do desktop yet, but it's what's called no code or low code development. And these are things that, so for example, I have a friend in town who's an accountant, works for a major pharmaceutical company, and she's not an idiot. She's a very smart lady. She's got a graduate degree in accounting, but she's not a developer. She's not in IT. I think she has, she could definitely be successful in IT, but she just doesn't have time to create apps. And she had a good idea, and she found Power Apps, and is now creating an application that's being used across the company. And so this is called no code or low code development. And the reason why this is important is because if you go to YouTube and you look up Charles Lamanna, he's the corporate vice president for, I forget which group at Microsoft. However, he does a presentation called the No Code Revolution. And in there, he says that Microsoft is predicting that over the next 5 years, there will be a need for 500 million, in other words, 500 million new applications. And that's more than we're creating in the last 4 decades. But most of these applications are going to follow similar patterns. So you're going to need, so something like, hey, I've got a list of data, and you select one and you see the details about it, master detail view. Well, that's something that can actually be created by the citizen developer. And the reason that I bring this up is because the pro code, which is the side that we're on, and it doesn't even mean code, it just means kind of like professional, IT professional. But you're going to start to see this stuff, because my friend, my accountant friend, she realized that, hey, I can actually start to leverage Azure resources inside of here, inside of my Power App. So she goes to IT and says, hey, I'd like to get access to these Azure resources. And they looked at her like she was nuts. Now, in their defense, yes, if an accountant or or somebody in marketing says, hey, I want to start messing around in the Azure portal, which is not what she was asking for. She's just saying, hey, I just need the whatever credentials I need to, and the endpoints and everything. Yes, that would probably freak IT out. But this is something that's going to start happening more and more and more. And it's not just for machine learning. This is across Azure. I think she needed access to a SQL database or something. And so what I'm saying is here, this will affect you. Another quick story. I know I'm taking up a lot of time, but there's another reason why I'm bringing this up, and also why Azure Machine Learning is so important. Back when mobile applications were first, when the smartphone, people started developing for the smartphone, it was a lot of the times you would check to see if you had network connectivity. Your app would, if your app needed network connectivity, you would check to see if it actually, and today it still does. But then ubiquitous networks came around, and phones started getting more powerful. Networks started getting faster. Bandwidth quotas started to increase, and so this wasn't a precious resource. This wasn't. It became more accessible. I saw a quote once. This isn't a quote from a long time back, but said it got to the point where that without a connection to the cloud or to the network or whatever, your phone was nothing more than an Angry Birds player. Of course, today Angry Bird does require a network connection. But what happened was network connectivity for apps went from basically a nice to have to a must have, to where it's implied, to where it's assumed, where it's an intrinsic part of any application. Machine learning and artificial intelligence is becoming that, if it's not there already. And so it's not just going to be the eggheads in the white lab coats with glasses thicker than mine that are going to be doing this stuff. It's going to be everybody, because machine learning is something that it wasn't nice to have. It's a must, then coming to a must have, and now it's to where it's just assumed that it's there. So like I said, this will affect you. You will see this. You cannot escape machine learning. If you take nothing away from this, take this away from it. Assume you have a problem, and this is your machine learning problem space. What should you do? Well, like I said before, the first thing you should do is look at Azure Cognitive Services. This is going to solve a vast majority of your problems. You don't need to train the models. You don't even need to know anything about machine learning. You just need to know how to call a REST API or leverage an SDK in a particular language. If you need to train a custom model, you should look at automated machine learning, because most likely you're going to have something like a classification or a regression model, and you're just going to need to train it on custom data. Automated machine learning lets you do that. If you need more control, Go to the drag and drop designer. So that's where you can set all the hyperparameters, choose a specific algorithm, pre-process your data, and pre-process your data, and also look at the results in somewhat real time. Well, not real time, but look at the results. Then, after you've exhausted all of that, then maybe you need to write some custom code. But so that was this is kind of my answer to the question earlier about saying, hey, do you have to learn Python to use Azure Machine Learning? No, you don't. None of this requires Python. This doesn't. These two, right? This one doesn't require any code. This one requires little if any code. And this one, yeah, it requires code, but it doesn't require Python. It requires, there are all kinds of different languages. And say you're using something like Go. I don't think there's an SDK for Go. I'm probably going to make a liar out of me, but at any rate, suppose there's no SDK for Go. Go can definitely has an API for making network requests. Guess what? You just bang away at the bare API endpoint. So that's all that I've got. Thank you for your time. I know that I said I was going to try to keep it to 90 minutes, and I've gone over that. Here's how you can reach me online. So LinkedIn, I'm Douglas A. Starnes on LinkedIn. I'm trying to stream more and more. Streaming is a completely different animal. Although I found that doing virtual presentations, when I'm streaming, I a lot of the times feel like I'm talking to myself. But doing more and more virtual presentations, I'm getting over that. But however, at Binary Chef, with the interesting spelling there. And then if you want to email me, douglas@douglasstarnes.com. That's all I've got. Let me see here. Okay, if I'm searching for Azure in Cognitive Services, there are about 80 marketplace choices. Does it have? It does have Machine Learning Studio, Classic Workspace. It does not have a link to get to the portal. Okay, so the classic. Okay, so Walter, what you're referring to, the Machine Learning Studio Classic. That was that previous product that I was talking about. That's not the Machine Learning Studio as it refers to today. That was the web interface that I was looking at. No, come on, let me back. There we go. This one here. That's the Machine Learning Studio. Now that Machine Learning Studio Classic basically is just an older version of the designer. So, so what you would want to look for upon searching Cognitive for Azure services, what you would actually look for is just machine learning. You're looking for a machine learning workspace. That's how you would get started in the Azure portal, and then you would wind up here eventually, and you would get the button to link to the studio. Okay, and then that's an incredible. Thank you, Douglas. Oh, great, another Douglas. Great minds think alike. So, Bill, I don't know if there are any other questions or if there's any administrivia that you need to take care of, but thanks a lot for having me.
Well, thanks a lot, Doug. And now that there aren't any other questions that I can see, and
okay,
we're at the end of the meeting. Let me know what you're interested in for future meetings, and we'll see what we can do to line up speakers for that. Okay.
All right.
Take care, everyone.
All right. Thanks a lot, everybody.
Thank you, everyone. Take care. Have a good evening.
All right. Thank you.